meaning that if certain things changed in the internal environment in your body, could you affect the shape of that curve? Yeah, you totally would. And we know that, for example, there are things that can cause the curve to shift to the right, in which case it would look like this. There are things that can happen to cause the curve to shift to the left. Now, which one increases the affinity? A right shift curve, right shifted or left shifted curve? Which one has a higher affinity? The left, because at any partial pressure of oxygen, it's got more oxyhemoglobin. That makes sense? Do you think one is good and one's bad? Or do you think they're both bad? Or do you think the answer is? It depends. Honestly, under resting conditions, they're both bad. Because here's what happens at rest. If you had something that caused your curve to shift to the right, and you go to the lungs, here, you're not going to fully oxygenate your blood. Make sense? So that's why shifts to the right are bad, is that you can't get 100% saturation. A shift to the left, easy to get 100% saturation, but guess what? Your cells are going to starve, right? Because of this left shifted curve, they're not going to drop off as much oxygen to your tissues. So neither one is good at all. It's just the way it happens. So what are some conditions that would cause this to happen? Let's see. Right shift curve, decrease in pH. Is that more acidic or more basic?
More acidic.
More acidic. So under acidic conditions, the curve will shift to the right. High temperatures, an increase in temperature, curve will shift to the right. Those are the biggies. Also an increase in CO2 levels. PCO2 would do it as well. And that would do it too. Those will change the affinity of hemoglobin. Now, obviously, that's under abnormal conditions. That's all I'm saying. If the curve shifts due to a drop in pH, the acidity, it's called the Bohr effect. I don't know why they just give a special name there, but the Bohr effect is due to the decrease in pH there. Got that. So then that means, what do you think would cause a left shift curve? Alkalosis, an increase in pH. Hypothermia, a decrease in temperature. Hypocapnia, right, which would cause a decrease in CO2. Doesn't cause a left shift. So these are environmental conditions, that's all. Yeah. So they cause those shifts one way or the other. This is the normal. This blue one's the normal one. We don't want to change our environment. Acidosis, alkalosis is going to affect your ability to bind and transport and deliver oxygen. CO2 also. You guys okay with this? Now, almost all of the oxygen in the bloodstream gets carried this way bound to hemoglobin. I think that